In this video, we're going to talk about how to solve for a variable if we have an equation with more than one variable. So there's nothing different. It's just going to look a little more complicated because we have less numbers and more variables. So we still follow the same steps. We're still following PEMDAS backwards. We're still isolating a specific variable. Our answer, though, will not be just a number. It's going to be an expression, which means it's going to have more than one variable in it, operations, things like that. So in our first example here, again, we don't have any numbers at all. It does tell us what to solve for. It has to tell us that. Otherwise, we don't know because we have a bunch of variables. So we can still separate our equation, and we're still going to get this guy by itself. So in this case, we need to get both rid of L and W. We need to take that to the other side. Because it's all multiplication, to undo that, we can use division. And so in this case, since they're both being multiplied, we could actually divide by both at the same time. So I'm going to divide both sides by LW. L goes into itself once, W goes into itself once, so we're left with 1H, or just H. And then on this side, V divided by L times W is just V divided by L times W. Okay. Isolating a specific variable is helpful if, let's say, we need an equation to talk about the height. So this original formula is the volume of a rectangular prism. Maybe we want the height of the rectangular prism, and so we can use this simplified version to find the height of any rectangular prism. So in this next example, it says to solve for C. That means now we're isolating the C. Now we're getting the C by itself. So if we want C by itself, this minus S needs to go to the other side. So the opposite of minus S, to undo that, we need to add S to both sides. So negative S plus S cancels. My C drops down. And M plus S is M plus S. We're just taking this vertical math problem and writing it horizontally because we can't do M plus S because we don't know what M is and we don't know what S is. Okay? So in this next one it says solve for B. Again, that means get B by itself. The reason is this is just to help us look at a specific variable if we're interested in that variable. So in this case, because we have a fraction, there's actually like an invisible set of parentheses here. And because we're following PEMDAS backwards, anything that's in parentheses must go absolutely last. So in this case, that B plus C, we have to keep and leave alone. And we actually have to get rid of this divided by D first. So the inverse of dividing by D would be to multiply by D on both sides. So A times D, or D times A, is A times D. On this side, we can do D divided by D, which turns into 1, and I'm just left with B plus C. Again, the problem says solve for B, so I'm trying to isolate the B. So this is the guy I need to get rid of. The opposite of plus C is minus C. So C minus C cancels. And AD minus C is AD minus C. In the next example, this is actually a formula we'll see a lot this year. It's called standard form. But standard form is not really useful for graphing. When we like to graph something, we like it to look like y equals mx plus b. So we may see this formula and we might solve for y a lot. Again, that means we're going to get y by itself. We're still following PEMDAS backwards. So in this case, we want to get rid of any addition or subtraction first. But since y is the one we're isolating, we're going to leave that alone for now. We want that guy to stay there and drop down the whole way. So we're actually looking at this as two numbers that are being added. since that's where we're starting with in PEMDAS. So we need to get rid of one of them. And since we're solving for y, we want to leave y alone. So we're actually going to get rid of the ax. And since that's a positive ax, we're going to take it away. We're going to subtract ax from both sides. So ax minus ax cancels. The by is going to drop down. And on this side, we're going to have c minus ax. You also could write that in reverse order as negative ax plus c. These are exactly the same. And now, since we're isolating the y, we need to remove this b. Since this says b times y, the opposite of multiplication would be division. So I need to divide everything. So you can divide the whole thing by b, which really means we're dividing each one by b. So however you want to write it is appropriate. You could leave it as y equals c divided by b minus ax divided by b. Or we could have left it as division of everything by b. So we could have left it like that. And this means the same thing. In our next example, we're going to solve for x. So again, when it says solve for a certain variable, that just means to isolate that variable, to get that variable by itself. So we're going to get x by itself. So I need to move the a to the other side and the b to the other side. I can't remove the a yet because it's a times x. And since we're following PEMDAS backwards, we want to get rid of this guy first, since that involves subtraction instead of multiplication. So the opposite of subtracting b is going to be add b to both sides. So my ax drops down. C plus b is c plus b. Finally, we need to get rid of the a. So we're going to divide by a. And I can divide the whole thing by a. And c plus b divided by a is c plus b divided by a. If I would prefer, this means I'm dividing everything by a. So I also could write it as two separate fractions. And these are both correct.